You've probably heard Billie Eilish's song about it. So how big is this star? Let's use our solar system for scale. The biggest planet in the solar system is Jupiter, which has a diameter of 140,000 kilometers. Let's make that a sphere. That's 38% bigger than the Earth. Now let's put 1,000,000 of these Jupiters end to end. That's 252 billion kilometers. But still, if you tried to stack them on top of each other, they only make it 2% of the way up to the smallest star in the solar system, our Sun. And even that tiny little star is over 100 times smaller than the biggest star ever found, a red supergiant or hypergiant star named Stephenson 218. If you want to see the star, it's located in the constellation Scutum, which is the Shield, about 19,870 light-years from Earth. Although it was discovered way back in 1860, it's so dim and so far away we only have a fuzzy idea of just how big it is. The size we currently ascribe to it is based on how fast its surface appears to be moving. And from that, we work out how big it must be in order to rotate once every 11 days like it does. If you know how big a circle is and how fast something is moving around it, you can calculate how long it takes to go all the way around. This is what we do with planets to find out their rotation speed. Just divide the distance around the planet by the speed at which things move around it, and you get the period of rotation. In this case, a full rotation every 11 days. But the same goes for stars. The trick is finding the distance around the star. To do that, astronomers rely on something called the Doppler effect. It's the same thing that makes a siren sound higher or lower pitched, depending on whether it's moving towards you or away from you. Except instead of sound waves, it's light waves that change in frequency as the star moves towards us or away from us. Because of this, the light waves from the rotating star are slightly blue shifted when the part of the star moving towards us emits light, and red shifted when the part moving away from us emits light. This means we can calculate how fast different parts of the star are moving, and therefore how big it is. It's worth noting that we can do this because the star is a red hypergiant, meaning it's big and bright enough to see in the first place. Most stars are too small and dim for us to detect changes in their brightness, let alone notice changes in the color of their light. So let's plug in some numbers. We know the star takes 11 days to spin once, which is 95 out of 500 seconds. Then we take the observed redshift and blue shift, which is 0.055, and multiply it by the speed of light. That gives us 16,150 kilometers per second. Finally, we multiply that by pi and divide by 2. That gives us 25,463,144 kilometers. That's the circumference of the star. But how do we turn that into a diameter? Simple. Divide the circumference by pi, and we get 8,145,923 kilometers in diameter. Now let's make that a sphere. That's almost 13 quadrillion cubic kilometers. In terms of mass, the Sun is about 333,000 times heavier than Earth. So let's make a sphere that big. That's 52,000 times the volume of the Sun. And yet that tiny little baby star is over 20 quadrillion kilometers in diameter. That's more than 21 octillion kilometers cubed. Now let's compare that with the largest black hole ever found. It's so big that if you took all the matter in the observable universe, including Earth, the Sun, and everything else, you couldn't fill up even half of it. That black hole has a diameter of 597 billion kilometers. So how many of those enormous stars would it take to fill up a single one of the biggest black holes ever found? The answer is 4. 4 of the biggest stars ever found would fit inside one of the biggest black holes ever found. And that's just the size of the star itself. That doesn't even include the accretion disk. There's also something called the Schwarzschild radius, which is the boundary around the black hole after which nothing can escape, not even light. For comparison, the Schwarzschild radius of the biggest black hole ever found is 180 billion kilometers. That's about the same size as the orbit of Uranus. If you were to squeeze the Sun until its Schwarzschild radius was the same size as the orbit of Uranus, the Sun would be 44 centimeters in diameter. You could literally hold the entire Sun in your hand, and I think that would hurt quite a lot. And yet that tiny little dot of a black hole is 66 trillion times bigger than the biggest star ever found. So just how big is a star like this? First, let's compare it to the most massive star ever found. It's called R136A1, and it's located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. The star has a diameter of 300 billion kilometers. And I know that seems mind-bogglingly huge, but compared to the biggest star ever found, it's just a mid-sized star. It's 21 times smaller in diameter. So the biggest star ever found is over 21 times bigger than the most massive star ever found. And again, this isn't even counting the accretion disk or the size of the black hole itself. It's just the size of the star. But what about the most luminous star ever found? That's a title held by a star called NML Cygni. It's located in the constellation of Cygnus, the Swan, and it's 20,000 light-years from Earth. Compared to the brightest star ever found, our Sun is 700,000 times less luminous. And that's really quite incredible considering that our Sun is actually a pretty average star. There are billions of stars brighter than our Sun in the Milky Way. Even so, compared to the biggest star ever found, NML Cygni is 15 times less luminous. That means if you had the brightest star in the universe next to the biggest star in the universe, the biggest star would still be 5 times brighter. Here's the bottom line. There are at least 3 stars bigger than the biggest star ever found. One is 19 times bigger, another is 21 times bigger, and a third is more than 2 quadrillion times bigger. It's easy to get lost in the immensity of space. When you hear numbers like this, it can seem impossible that anything could possibly be that big, but thankfully there is a way to get a sense of perspective. Take, for example, the fact that if you stacked up all the atoms in the observable universe on top of each other, they would form a column 139 billion kilometers tall. That's the height of nearly 40 billion Burj Khalifas, the world's tallest building. Or imagine trying to walk from one end of the Milky Way to the other. Even if you walked at the speed of light, it would take you 40,000 years. These are just 2 examples of how even the most mind-bogglingly large numbers can be put into context. Of course, the size of the biggest star ever found is just one of many incredible facts about the universe that we continue to learn more about all the time. From the age of the cosmos to the number of galaxies in the observable universe, there is so much that is truly amazing about the world we live in. But sometimes it can be hard to keep track of all the new discoveries and findings that are constantly being made. And that's where SEI Showspace comes in. Our channel brings you the latest news and discoveries from the world of space exploration and astrophysics. Whether you're interested in exoplanets, black holes, the James Webb Space Telescope, or any of the other amazing phenomena that occur in the universe, we have something for you. So be sure to subscribe to SEI Showspace and join us on our mission to explore the unknown.